In this video, we are going to learn about galvanic cell. At the end of this lesson, students should be able to use the standard reduction or electrode potential values to compare the relative strength of oxidizing agents or reducing agent, calculate standard cell potential E0 cell, and predict the spontaneity of a redox reaction. The following diagram shows an electrochemical series which is also attached to your lecture notes. Please refer this as we study the electrochemical series. Some facts about electrochemical series: all ions involved are aqueous. All half-cell reactions are written as reduction equation. Oxidizing agents are found on the left of the half-cell equations, while reducing agents are found on the right of the half-cell equations. We can use electrochemical series to compare strength of reducing and oxidizing agent, as the example follows. We have three species, Cu2+, H+, and Zinc2+. If we are referring to the left of the equation, which are the reactants, we are referring to the oxidizing agent, where the more positive the value of E0, the more stronger the species as oxidizing agent. So here, the more positive is Cu2+, followed by H+, and the last one is Zinc2+. Or we can say that Cu2+ is the strongest oxidizing agent, followed by H+, and Zinc2+ is the less strong oxidizing agent. But if we refer to the right side of the equation, which is the product, where we have copper, hydrogen, and zinc, we are referring to the reducing agent. To compare the strength of reducing agent, we are going to look at the more negative value. The more negative value the E0, the stronger it is as a reducing agent. So here we have the more negative belongs to zinc, followed by H2, and the last one is Cu as the least strong of reducing agent. So you have to remember an electrochemical series. If you are referring to the right side, you are referring to reducing agent, while the left side refers to oxidizing agents. Example: which species in each pair is a better reducing agent under standard state condition, Na or lithium? First, we write down the equations from electrochemical series, including the E0 values. From the E0 value, we know that E0 for lithium is smaller or more negative. Hence, lithium will become a better reducing agent. Remember, if you write Li+, your answer is wrong because, as we have learned before, reducing agents refer to the product, which is Li. We can also use the electrochemical series to calculate standard cell potential E0 with the formula E0 cell equal E0 cathode minus E0 anode, or E0 cell equal E0 reduction plus E0 oxidation. So how do we know which one is cathode and which one is anode from the electrochemical series? We can know by the more positive the E0 value, the stronger the oxidizing agent. Hence, the greater the tendency to be reduced. Hence, it becomes cathode. While the more negative the E0 value, the stronger the reducing agent, the greater the tendency to be oxidized. Hence, it becomes anode. So, if you have a more positive E0 value, it becomes cathode. But if you have a more negative E0 value, it becomes an anode. For example, we have the following E0 values for copper and zinc. We know that the more positive will become cathode and the more negative will become anode. So we can use the formula E0 cell equal E0 cathode minus E0 anode, and we will get the value of E0 cell as positive 1.10 volts. Or we can change the equation at anode into an oxidation equation, which is zinc solid produce zinc 2 plus 2 electron, where the sign of E0 will change into positive 0.76 volt. By using the formula E0 cell equal E0 reduction plus E0 oxidation, we substitute the value 0.34 from the cathode plus 0.76 from the anode that has been changed from negative to positive. So, we will get the value of E0 cell as 1.10 volt. Same answer like the first formula that we used. Lastly, we can use the electrochemical series to predict spontaneity of a redox reaction. Under standard state conditions for reactants and products, the redox reaction is spontaneous in the forward direction if the standard EMF of the cell, E0 cell, is positive. But if it is negative, the redox reaction is non-spontaneous. For example, we have zinc and copper. As we have calculated before, using the first formula, we will get the E0 cell as 1.10 volt. And if you want to use the latter formula, we have to remember to change the sign for oxidation from negative to positive, from negative 0.76 to positive 0.76, and we will get the answer as 1.10 volt. So, if you look here, both formula give the same answer, which is positive. Positive means that this redox reaction is spontaneous. Next example, we have to calculate the EMF and construct a cell notation for the following cell. So, first of all, from the electrochemical series, we write the reduction equation for Sn and Mg, including the value of E0. From the value of E0, we know that Sn will be the cathode while Mg becomes the anode. By using the formula E0 cell equal E0 cathode minus E0 anode, we will get the answer for E0 cell as 2.23 volt. And lastly, to write the cell notation, we must write first the equation at anode. Remember that at anode, Mg undergoes oxidation. So, we have to write Mg first, then followed by Mg2+, followed by double line representing salt bridge. And then at cathode, reduction takes place. So we write Sn2+ first, followed by Sn solid. So that's how you write cell notations as we have learned before. That's all for this video. Thank you.